So hello everyone, welcome to the very first day of the Jacamar tutorial. My name is Alex Scott, my co-host here is Paul Bryant. Paul is from Oak Ridge, I'm from Livermore. And today we're going to be talking about Jacamar, specifically related to setting up a Jacamar instance, likely from the perspective of a sysadmin or somebody who has rootful access to both an HPC cluster and admin access to a GitLab account. So if that's not you, tomorrow we're going to cover more the user side of how you can use Jacamar to spin up and launch your testing infrastructure across HPC machines, as well as running kind of reproducible workflows on HPC machines through Jacamar as you, kind of using the HPC cluster in a reproducible way via pushing up your code to GitHub. So feel free to attend tomorrow's in the case that you didn't get the email and that is more what you're interested in. But it looks like we've only got 33, 34-ish people in here. So I'm guessing most of these folks actually are sysadmins. So from that perspective, I'll go ahead and get started just on a little bit of what Jacamar is. We're going to be sharing this presentation tomorrow, but there is two diagrams in it that I think make a helpful point. So the first question folks might have here is maybe you've heard of Jacamar through a conference, through other folks talking about using it, and you really want to know, why aren't we just using the GitLab runner on whatever resources that I have? Like why specifically is Jacamar interesting? And to kind of step back and give a little bit of the history is CI/CD systems really grew up inside of the cloud, inside of environments where you're isolated from all of your peers in a multi-tenant setup via virtual machines. So you're often running as root inside of the virtual machine, and they weren't built for clustered environments where we have multi-users or multiple users on a single machine, where you have a multi-user environment on either a virtual machine or bare metal hardware. And so Jacamar really lets you run as each of the individual users who pushed code up to GitHub or up to GitLab, instead of running as a single user, whether that's a service user or whether that's some kind of rootful action on something like a virtual machine. So Jacamar handles kind of this downscoping, and Paul's going to get into this a little bit later with all of the security features of Jacamar and really why it is architected the way it is. But from a high level, I'll just say that Jacamar provides the ability to run, just a couple of runners, maybe a runner on each machine or a runner on each login node in the case of an HPC cluster. And instead of having to run specific runners as each individual user, you're running one top-level service that is then downscoping into the individual users that are executing. And Jacamar does that via Java Web Tokens. It's basically doing a mapping from GitLab users to your HPC users, and we'll get into that a little bit more later today as well. So the diagram that I wanted to show here is that you've got your GitLab server. Jacamar doesn't replace the GitLab runner. Rather, the GitLab runner comes with a couple of different executor types, including one that's just called the custom executor. And so Jacamar implements this custom executor interface, allowing us not to have to rewrite the GitLab runner from scratch, but to be kind of a plugin for the GitLab runner, making it aware of HPC and multi-user environments. And we're going to get into in just a little bit. Paul is going to show the process of setting that up, of configuring both a GitLab runner on a machine, as well as integrating it with Jacamar. Jacamar also, I'll skip this a little bit. Jacamar also plays with a bunch of the different batch executors or resource managers out there. So stuff like Slurm is definitely the most popular, but PBS is been around there and might be integrated at your specific center. Here at Livermore, we're starting to move over to Flux, which we're just kind of starting to see as the next generation Slurm. So Jacamar can talk all of these, and it can either allow users to launch jobs on the login node for a specific machine, or it can submit your job to Flux or Slurm And then the user's job wakes up inside of a batch allocation on one of the compute nodes without the user having to do any manual work for, running a Slurm job and then having to go tail out the output of that periodically. Jacamar handles all of that for the individual users. Jacamar also has support for run mechanisms. And so if your users want to be running inside of containers, for example, Podman, Charlie Cloud, Singularity, or Aptainer, Jacamar supports all of those, allowing you to run containerized workloads on HPC machines without having to have something like Docker installed, where the user's job can look identical to a cloud job, where you just put the image tag inside of there. And then the user's job essentially wakes up inside of that containerized environment on a compute node, and Jacamar handles all of the pulling and starting of containers for you. So without further ado, I'll hand it over to Paul to walk us through an interactive session of how to go set up a GitLab runner, how to configure it to work with Jacamar, and how to install Jacamar onto a machine. I will be around in the chat. If people have questions, I'll try to answer them to my best ability, and then I can pause Paul if a good question comes up at a specific moment and let him answer those.
We're going through the admin tutorial on the Jacamar CI documentation. You can follow along. It's been written to hopefully have a self-driven aspect as well, but you don't have to here, or if you don't have resources and you're not set up, that's also okay. Because I'm going to go through it and talk a little bit about some of the configurations and the decisions and kind of how they work under the hood a little bit, and be able to answer any questions. Kind of before we deploy it, it's worth just highlighting quickly like what it looks like, what it's running. The idea primarily is GitLab is running as some sort of privileged user on the host system. That runner is managing the communication with the server for both retrieving jobs and updating the server on the state of jobs. And we're configuring it to point to an application called Jacamar auth, and that is envisioned to run as the privileged user and handle things like the authorization flow and the actual dropping permissions to the authorized local user account. And then also, then there is a just Jacamar application that runs as the user and actually handles realizing, here's all the context the runner has provided about the job, here's the job script. Now, how do I realize that and run that on the local user environment using local resources, maybe just the user shell, or potentially the interacting with the scheduler and or container runtime like Podman, Charlie Cloud, or Optainer. So to get started, we're going to focus on the local environment we've set up to kind of do this demo. But it's kind of been written so you can run it in a container as well, if that makes it easier to test locally on your machine. And it's written to assume that your GitLab account name is the same as the user you're targeting for downscoping. So in like a production instance, this is probably LDAP managing both the GitLab accounts as well as your local HPC accounts. However, I'm going to show you later on how you can work around that, basically using any sort of script you would like as an admin of the runner, and what that and give you at least a little bit of an example of what you could do there if that's not the case on your system. So we're going to have to skip a few of these steps because we've already installed GitLab Runner, on here. Version-wise, Jacamar only, the big thing with Jacamar is fairly flexible. You'd have to go back quite a ways to get a version that wouldn't work. However, you should still try to aim to have your runner version in line with the server version. I think that's the documented best practice from GitLab. And then Jacamar is also installed, and it is the latest version, which we would just advise running that. So we can start by registering a runner. We're just going to do group runner. There's different levels of runners. You can do system runners, which is probably what you're doing if you're offering it to everyone in the GitLab instance. This is just a little easier to manage. Give it tags. And we can just create the runner. GitLab gives you some options about basically what the operating system is. This is mainly going to affect nothing in our case. We're just going to use the Linux and copy the command that they give us and run it locally. You're going to see tokens here. Normally, you would not want to display those to people and you'd have to reset them, but this is all getting deleted after the tutorial, so that's okay. We're going to target this instance because I forgot behind a proxy and it's using, I didn't change it to HTTPS. We'll give it a name and we'll select custom, type for an executor, and then that starts the configuration file. Because we're running it as root in this case, the configuration ends up in etc GitLab runner. Any non-root user will create, when you register a runner, they will create the runner's configuration file, this config toml, in their home directory under a .gitlab runner folder. We can actually, we'll just restart it because I forget where I left it. When you change the runner configuration file, you do not need to restart etcd, but if after you install it, you might need to, the runner itself. We'll take a look at it. And it is running, and it is communicating with the server. So we know it's up and running, and in fact, we can see that it is online and available. So that's the first bit of registering the runner. Now you've gone through the runner registration. Now we have to actually configure the runner itself. So a couple of values that might be worth talking about here is concurrent value, and that is how many jobs the runner can run, realize at any given time. With Jacamar, there is no good recommendation I can give you on what this value should be. It is dependent on your host system and how many resources you're willing to give to potential CI jobs. A shell executor would use a lot more than a batch executor when you've configured it, because when interacting with a Slurm or a Flux or a PBS, Jacamar's resource utilization is very, very low. But when it comes to shell jobs, where just users are running things on the controller login node, can be particularly demanding. Token that is used by the runner itself to communicate with the GitLab server API for the purposes of polling jobs or pushing information back to them. So we're going to start by copying over this configuration really quick, and we'll kind of talk about it. And we'll forget this. Okay. And toml spacing doesn't matter, like not like YAML where tabs and spaces matter. Toml doesn't matter here in this case. So with the configuration of this, we'll talk over here. The custom executor from the GitLab runner splits a job into 4 primary stages: config, prepare, run, and cleanup. Run is actually split up into even more sub-stages, where each one is a bash script the runner generates. And this bash script is the same sort of thing it would generate for its concept of shell executor or any of its other executors. It's generating this script based upon the users, what they want to do, or some default behaviors. So a run script would be like get sources. That's the get command, the script the runner has generated to run get clone and fetch and all that. Or the build script, where that is the actual job script the user has written and the runner has realized that in a single bash script. Config is something that exists for the custom executor, and same with prepare, where it is an opportunity for the custom executor, in this case Jacamar, to prepare the environment and to set up its configuration and to provide context back to the runner itself. So during config exec, what we're doing is we're ingesting this this configuration file for Jacamar that decides, okay, what does a job look like? How are you downscoping? What can users do? What users can run on this, and those sorts of things. It's looking at the context the runner has provided Jacamar about the job and making decisions based on that, and establishing some concept of state about the job itself. Because every time Jacamar is launched, it doesn't know what's happening. It has to. It doesn't have any concept of state other than what the runner provides it. Rare is fairly straightforward. Just in some cases, it's just like here's a good example. If you're using a container runtime, it's in that step, it's cloning, it's pulling down the images you require and making sure they're available locally before moving on to the next step. And cleanup is, as the name would imply, cleanup. And the reason a configuration file is passed to cleanup as well is a behavior of the custom executor is if it fails during configuration or any stage, it's going to run cleanup. So the assumption is there is a chance that it has failed and it doesn't provide state, and Jacamar needs to know what it needs to clean up. So it needs to reread its configuration to see what needs to happen. So Jacamar has basically arguments you can pass, and if you just run Jacamar -help, it will provide you details on those. But once you set this up one time, it's something that you don't change. It's more of a one-time configuration for the custom executor, and from there, the rest of the changes you might make or need to make will all be in this custom toml file, which we'll create in a second. Okay. So let's start. I'm just going to copy this entire thing in, this entire configuration file in, and we'll start just going through some of the options available. And there's a lot more in the documentation. And I guess one note I'll make is getting it started initially is fairly simple in terms of configuration requirements. You actually don't need all of this. What you really just need is the executor, the data directory, and the downscoping, and that's it. The rest of this kind of added because I think they're helpful, especially for the purposes of this tutorial. And a lot of the configuration options that exist are meant to deal with edge cases that other centers or machines within a center have run into and required in order to realize the sort of CI/CD on their system. So the first one is an executor. This is analogous to the GitLab executor in many ways. Shell being it's just going to run on the user's local bash login environment. Then there's other options like Glux and Slurm and PBS. Those are the three primarily supported. And then datadir is the target for data that the custom executor is going to where it's going to create folders, where it's going to set up folders for the users, and where the users get cloned, and those sorts of operations are going to occur. There's a lot of options here. Just home being it's going to end up in the user's home directory. You can have an explicit location for this. You can provide users with options to move this around based upon environment variables they provide to the CI/CD job. It is hard to say where you should put this. It is where you want users to clone their, by default, where you want users to clone and build their software. So this might not be home in your instance. You just you might have to move it around, and there's more documentation and examples about some options you have available for you in that space. Limited data builder is a rather new feature. We talked about that runner token in the config toml. That actually appears, part of that appears to the user in their CI/CD variables in conjunction with their path for the build directory. It's called the runner short token. You'll see it in predefined variables. I think it's CI_runner_short. And I think it's about 6 characters of the runner token. And that needs to be there because every job has to run in a unique space. And the default assumption is you might have multiple runners. For instance, maybe I have a shell runner and a batch runner, and they both have their own token, and they both need to run in different locations. However, that gets problematic if you have a lot of runners across many different clusters, and suddenly you have this sprawl of folders your users are leveraging. Limited build directory is a relatively new feature added sometime, I think earlier this year, that has Jacamar race to claim concurrent directories, even across multiple machines. So it removes that runner short token and it cuts down on the sprawl of, oh, I ran 5 jobs and they all ended up on one machine one day, and 5 jobs and they all ended up on a machine another day. And suddenly I have 10 copies of my repo, and normally I only need 2. And then this is kind of to help prune that down slightly. It's not a default because turning it on, if you have existing systems, will exacerbate the problem of users using up a lot of their space in their quotas for large clones, because all of a sudden they'll have the old file paths that never get cleaned by default, and they'll have these new ones. So I'll have it on for the demo. And if you are deploying from scratch, I'd recommend trying it out and seeing if it works for you, because it will help you avoid issues later down the road. Downscope is the target for our operation to drop permissions. There's options like set UID. There's sudo as well. And there's one where the only other option is like none, which is there is no set UID, which I'll touch upon later. There are some caveats to that. It won't run as root, for instance. Downscope set UID uses Go's implementation of set UID from the official standard libraries to help drop permissions from Jacamar auth to the Jacamar application running as the user. And we do a whole bunch of other stuff to make sure that it's their effective UID GID, for instance, that it's not sharing a terminal, those sorts of steps as well. And finally, logging is something enabled by default. By default, it's actually to systemd. However, you have some options with locations. For the purpose of this demo, I'm just going to dump it to a file. And if you're running in a container, it makes life easier. For the demo, don't run Jacamar actually in a container on a production system. There's really no reason to do that. And we'll do it to debug level. So that's kind of the configuration option there. We made the changes. Runner's up and running. And watch it, just turn this on really quick. We'll watch this. And we'll kind of use the runner to run just a quick job. So here is our job, our test job. We're targeting the tutorial runner we just set up. So we're using GitLab standard idea of tags and how we select runners. This is helpful, especially if you're offering users a number of runners, both ones that run on HPC clusters, or maybe runners that run in different locations, or traditional like Kubernetes or Docker executors. Having some flexibility there is nice because they can run jobs in different locations. The ID token, and this is an important thing, Alec mentioned, GitLab has, in 17, they shifted from the CI job jot being a default behavior to something users have to explicitly decide a job will have, or decide at the default level for their CI/CD pipeline that all jobs within that pipeline will have an ID token created and provided to the runner. And this is a jot that the GitLab server signs. It generates and signs it. You can customize the audience, and Jacamar you can configure to expect specific audiences, but in the case of in Jacamar, it's being handed the jot not by a user, but by the CI job itself. So checking the audiences is required as traditionally when you're dealing with a lot of different jobs potentially, or different jobs for different audiences coming to your system that users are handing to you. This has to be defined. You, as an admin, can change what variable you expect for an ID token. And Jacamar will, if it doesn't find an ID token, provide users with a clear error message. I'll show you in a second, explicitly saying, hey, it's missing. Copy this line of text and put it in your job, and we'll run. So this job is, Jacamar will basically, when it starts in the config, it will go to the JSON web key set for the GitLab instance you have, grab the public keys and validate the jot itself, and then take the payload from the jot and use that as the primary source of information for authorization. There's other context provided, the environment variables and configuration files, and it kind of combines all that. But the most important bit is the jot, because this decides who the user is. Because when you run a job, it associates the person who triggered it with the jot that's being generated. And this is something GitLab like officially supports in terms of how it keeps track of who triggered a job, and it's something they fix if there's ever an issue. So it's an important part of their like auth model. So it's like that, at least this ID token and who owns a job when it's triggered is fully supported upstream. So it's not like we're kind of piggybacking off of anything. So we'll just edit this file really quick. Okay, that is running. Okay, so we started the job pretty quick. It's run all of its downscoping, and it's run the get sources script. I ran it earlier, so there's nothing to clone. It's run its commands. You can see it is running as me and not as root, and we'll actually show that here in a second. Let's grab this command. And we can see that kind of just a subset of what you'll see. You can see the runner itself, the system service, and Jacamar auth is running as root. We've dropped permissions to Jacamar as my user, and then it is creating a clean bash login shell to actually run the job script itself. So this mirrors the behavior from the shell executor where it generates this clean bash login shell for the user and it runs. The fun bit about that is depending on what the user does in their login environment, this gets tricky. Jacamar actually passes an environment variable to this login shell. I think it's just Jacamar CI underscore shell. I should say that in the docs as well. Users can check that and then break out of their login environment, their login scripts if they need to, if they have something particularly problematic, like replacing the shell a bash login and trying to log in at give themselves a C shell, for instance, or something along those lines. Everything the runner generates is bash. It generates a bash script. It expects bash. There is no way around that. So it's always going to be users bash shell that is they get the login environment for. So that is running still. Actually, it might be done by now. And that's it. Job succeeded. So that is it. That's it for like just Jacamar itself. Now, if we take a look, a little less accepts. So a little less exciting because it's in their home directory, but one thing that's worth highlighting is if the data dir is in some shared location, Jacamar will attempt to, the user Jacamar will attempt to create a folder that's owned by the user, the top level being just 700 by default, and is very strict about that. In fact, so strict that if I changed this folder permissions and made it world readable, Jacamar is going to fail the next run. It's a little different in the home directory because well, it doesn't, it's your home directory at that point, so it's probably 700 already. But it's a little more exciting if your data dir is ending up in a more shared location where it's not already protected. But within this folder, you'll see 3 folders created: builds, cache, scripts. Scripts is something that is created every single job. Jacamar just uses that to store bash scripts or other things that need to be stored as files for the duration of the job. It's cleaned up during that cleanup exec stage. Caching is local caching, if you're familiar with the GitLab cache mechanism. With Jacamar, you can only use local caching. You cannot use buckets. How GitLab keeps the secret safe for like caching buckets is users don't, traditionally if you're using a Kubernetes or Docker executor, users don't get access to all the environment variables and they don't get access to the environment itself. So they can run things like, I'm going to upload this cache somewhere and I'm going to use this secret for my S3 bucket. It's a little bit different here because it's running in the user's like login node. So that's just not safe to do. I don't think anyone's ever asked to do that. I wanted to mention that just in case. And then builds is the build directory. And so what we can actually see here is, oh, actually, is the folder structure is a little bit different because we have that limited build directory on. And so we have this concurrent value that Jacamar is going to claim. And we have, well, we have actually nothing in here because it's an empty folder, just the admin tutorial and the example, and that's the group and project. And then in here is the actual clone itself, just our README and our GitLab CI file and our Git. And Jacamar kind of, that's this folder structure underneath the 000 is created by the runner itself in their Git sources script. And GitLab handles the actual creation of like how the Git folder is created and how the CI job token is used in this space. Depending on what you've configured or what level your GitLab runner's on, Jacamar does influence the Git sources script, for instance, and the artifact scripts. Because by default, we assume things like proc are not hidden just to be safe. And in which case we make sure that at least in the runner generated scripts, you're not going to potentially expose a token via command line options. So we kind of take some steps there to protect users. Obviously, in their script, they can write anything, and then we can't really control that. So we have that. So if you're following along, there's some next steps you can kind of explore to see what happens. Things like changing the folder permissions, deleting your users, and seeing what error you get. There is an idea of unobfuscated error messages. So if you run into an error with the user not existing, Jacamar is not going to give the user the full context of the error because by default it assumes that you might not want to expose everything to the user. Because how the custom executor works is it's just going to take standard out, standard error from Jacamar and Jacamar auth and just post that back to the server. So we don't expose all the errors. We do, however, expose all the details. Let's just copy this command. We do expose all the errors and all the messages in the log file or systemd logs, whatever you have configured. Providing information like the message itself. So we have clear indications of, in this example, who is authorized to use the job. We provide more details about what is context provided from the runner, what's happening, and have a clear link back to the runner itself using the runner short token in this example, and also the job, the CI job. So now you have a link between what Jacamar is doing and behaving, what the runner does. You can check the runner logs, and you also have ultimately to go back to the server because it is the most authoritative source of information, and the runner and Jacamar all trust what it says to determine what happened. Because Jacamar itself doesn't handle authentication, it's really just focused on authorization of the user. There's more options such as changing things to a batch executor, which we can do, which is by default fairly, oops, that's the wrong configuration file. There we go, which is fairly straightforward. In our case, there isn't a whole lot to it, but we just flip this over to Slurm, and now it is going to submit jobs into the cluster, the Slurm cluster, instead of running them locally in the shell. Fingers crossed. Hopefully everything is working. As we run that same job using the same runner, but with the configuration file changes. Yep, there we go. We submitted a job to the cluster. It is running on one of the compute resources, and Jacamar will kind of follow along and see that to completion. This will fail because by default, Slurm looks for saccount. Saccount is not enabled. However, we have an additional configuration option that instead of using saccount to verify this completion of a job, we'll use sq. So I would imagine most environments that is not the case on, and you would have saccount configured. And so finally, the last bit I think is helpful, at least for this portion, and we'll open up for questions, is to go through like run as validation, because this is this exception to the idea that LDAP is managing users in both cases, because that might not be true for your instance. You also might want more fine-grained control. You might want to actually check against another system before you allow a CI job. You might want to use a service account. That is through this run as configuration. So this is a really simple example where I look at a GitLab user being provided. And then if it is the expected user, I'm going to echo back some JSON to Jacamar auth, because this all happens in that privileged application. And Jacamar will say, oh, okay, great. I'm going to use this username as the target for setUID and all other rules from now on, and it will take that. If not, if this script fails for any reason, or the information posted back via standard out is not valid JSON, Jacamar will fail the job completely. And so where this kind of lives in this flow here is this authorization flow. Jacamar gets the job context from the runner. It validates the JOT first thing. Well, first thing, it actually reads its own configuration in the environment and parses the environment to make sure that it is expected, like, oh, you're not trying to insert like illegal characters into this environment variable. So once it does all that and validates the job context, it validates the JOT itself. It executes the run as script, grabs the new user if there is one, and then continues on to sort of these allow block lists that exist to give you an easy way to check for the user's local GID, like UID, like, oh, is it allowed based upon these lists? And then validates the user and targets them for downscoping. There's more here in the documentation and examples and more details on run as validation, along with the context for handing your script about the job. So these are helpful. And you have a number of different overrides with run as well. And we found this was the best route in terms of like supporting an ever increasing number of edge cases where you might need to make a decision on what user is running, or maybe you're having a group of users target specific service accounts to run as instead of their old accounts or their like local accounts. So you can do things like modify the data dir that they're using. You can also do things like provide specific messages to the user, and also have error messages that are just logged by Jacamar that aren't sent to the user. So those are kind of just helpful little options available to you. And there's also features as well tying to user identities, thanks to efforts from Kitware, to like they're tied to user identities from other login sources. So if you are juggling multiple distinct potential like OAuth or SSO like type solutions at your login page, and you're like, oh, it's not just LDAP, it's not just SAML, one single SAML, I have multiple like OAuth providers that users can log in as. That kind of functionality is supported, but you'll have to realize the like last mile implementation of it with the kind of script you write. The rest of this kind of goes through other options available to you to deny users access, like shell allow lists. Basically, like, oh, if you expect users to if you're flipping accounts to no like login shells before turning them off or something, you can make sure Jacamar observes that reality so that it won't run a job and it will check the user's shell before starting the job during that config stage. And then some options with regards to downscoping. So yeah, but if we change this here, change this. Let's fix this so it runs really quick. Go back to our example really quick. We'll remove that sleep command since we don't need it. We'll go look at our pipeline. Submitted the job, should finish in a second. There's some options for configuration when it comes to batch executors, including some flexibility and an NFS timeout. This is if your file system you use to connect compute and login, maybe you need more time potentially between the completion of a job when Slurm thinks it's completed and when all the files are going to be available. The example being you generate a file in the compute node, and Jacamar is like, oh, great, I'll upload that as an artifact because the user wants it because there's an artifact step, but it's not quite available on the login resource. So they give you a little bit of flexibility there. It's not exciting implementation. It is literally just a sleep command. Jacamar's gonna be like, I'll just wait this long for you, because there's really no other way for it to know if everything's present. So yeah, in this case, the job completed successfully. We just saw that it got a completed state, and that would be an equation of like this single CI job was submitted to Slurm, and with just those couple changes, we went from having shell to a Slurm executor, and this one most people wouldn't have to enable. So I'm going to stop for there because I know that was a lot, and I feel like I probably talked way too quick, but I want to like allow time for questions, and to kind of explore any specific requirements people have that maybe aren't covered here or weren't covered in the docs if you had a look at it.
So Paul, while folks are getting set up, I have a couple of common questions kind of seated here. Yeah, as folks are writing things down or getting ready to unmute themselves and such. And the first one is probably when you're running batch executors and shell executors, what's the best practice for having both of those available to users on the same machine? Is it to run 2 instances of the GitLab runner, targeting different tags? Is it just to configure Jacamar to support both?
So you would run 2 different instances of the GitLab runner, each with their own separate tags, which would be the best. You can go a step further as well, because what that would look like is in that GitLab config toml, a runner it's an array of a list of array of runners, yeah, and each one being its own like ID token, which equates back to the ID of tags on the server, because tags are managed server side. And that means they're all kind of lumped under one runner config, so one ID of concurrency. So yeah, you can kind of edit it there. You can go a little further in the config files as well on the runner side. And I think you can narrow down, I believe you can narrow down concurrency at the runner level as well. So you can look at a shell runner is like, I only want to have 5 instances running because I'm limited on resources, but batch executor, oh, I want 15 of it. And I want to encourage users to use this instead for submitting jobs because resource-wise, we're not as constrained there.
Yeah. Yeah, I think that is exactly the answer that I would give to folks, and that's good. Oftentimes folks, extending on batch executors for a second, we really oftentimes get the question asked like, my job was sitting in the queue and then it timed out and it got canceled by Jacamar. Do you want to talk about a little bit of why that happens, first of all, and then any best practices for like increasing that timeout?
Yeah, that is a fun problem. So jobs are limited based upon like by the server initially, because it decides like this is a CIG job token. The user has configured a job is going to last this long, or it's the limit of the runner itself. So let's say we say jobs can only last a maximum of 1 hour. That means when it creates a job, unless the user has defined a lower time, it's going to create tokens at 1 hour for maximum of 1 hour. The job is 1 hour. The ID job token is using to clone is 1 hour. And so that means that if it sits in queue longer, it times out. So oftentimes right now, there's one way around this that works best, which is increase the timeout of batch executors, just your Slurm and your Flux and your PBS ones, to multiple hours or maybe even days. So that way, if they're sitting in queue, they can pick a very long timeout for their job. And instead of relying on that to end a long running job, they configure their wall clock on their like scheduling arguments, their actual submission itself. They can be like, oh, this job should only run half an hour, but it might sit in queue half a day before it runs. There is a new feature, well, relatively new, in Jacamar called Schedule Our Actions, and that is the idea that you can create a bit of a workflow within your CI/CD job, or your pipeline, and it submits jobs at the very beginning to claim resources. So I'm going to create an allocation at the beginning, and then subsequent jobs in the pipeline would use that allocation. And then at the end, you'd have a dot post like stage that cleans up everything.
Mhm. Cool. So it looks like we've got 3 questions so far. Folks, feel free to keep writing them down. I can announce them or read them out to folks so that they're not everyone has to read them in chat. The first question is really asking that oftentimes in CI/CD systems, it's best practice to go write something like a bash script or an executable instead of putting all of your logic inside of, say, your GitLab.yaml or if you're using GitHub Actions or something, just to make it more reproducible across systems and also lower the barrier when you move over to different systems. Would you expect any differences between a locally running that bash script on, say, a compute node or running it through Jacamar?
No, so the goal is whatever you can do on a compute or on your login shell would be the same behavior you see in Jacamar. So we do everything we can to make sure that that behavior is always the same. The only difference by default is it's a non-interactive shell. So if that normally does not matter for most people, I assume. So I think you'd see the same behavior.
Cool. So the next question from Wooter is talking beyond like the security considerations documentation. Do we have a write-up that it is something that we could give to an HPC center or a lab's like security staff that is maybe not HPC specific? I don't think we have a document quite like that yet, but I do think that this is a good way to jump into that conversation to talk about the security considerations of Jacamar. Jacamar on its own, I think is about as secure as users running something on a machine, but it does make GitLab another interface to your HPC machines. And if you have a disjointed set of users, Paul and I were just talking about this yesterday, where maybe you have more users have access to your GitLab account than have access to your HPC center, you could have a little bit of trickiness there where all of a sudden now if you've gated it in the past based off of just the authentication step of getting into the machine through something like a Bastion host, now your users could bypass that and they could execute on an HPC cluster through Jacamar if you made those runners globally available to everyone. And I think the right way to limit that, like Paul was talking about earlier, would be to make the runners associated with a group, perhaps create an HPC group, and then everyone who has access to the HPC cluster becomes a part of that HPC group in your GitLab instance. But I'll just hand this off to you, Paul, a little bit more generally to talk security and Jacamar. I think Jacamar does make GitLab runners the most secure for HPC environments, but if you want to talk specifics there.
I think you did a really good job covering it. Like the most important all this is your GitLab server and how you what you allow users to do, what users you allow on, like across this, like how many users you allow on, what and how that's configured. So for instance, like if you want to limit access to the machine, you might have to also limit access to like personal access tokens on the GitLab instance, and how long those live by default. You might have to look at how users connect to that and when they're allowed to connect to it. What users are allowed to mirror, and is the mirroring triggering jobs? Do they know what that implies? Because suddenly they're responsible for everything running on the runner. So all those are things that are potentially tricky depending on how long your GitLab instance has been there and how people are using it. But if it's something that is already just staff only, for instance, and it's already the teams that are using the systems, it makes life a lot easier, and you don't really have to usually change too much about policy about your GitLab server. Jacamar also provides some configuration options to limit when jobs will run, not just by users, but by how they're triggered, for instance. So there's a variable the server provides called the pipeline source, and so Jacamar can be configured to observe this source, where it's like, okay, a job was triggered by a push, for instance, or by a web action, or by a parent-child pipeline. Those things might be okay, but there might be other options in that list that you're like, I'm not comfortable with those. And so we kind of provide some options and some examples of those in the configuration, like docs as well. So that might be another way to limit it, who can use it, in addition to some of the off options we kind of highlighted in the tutorial section. Um, those are, I think, are the it's intimidating to enable, because of those kind of how many jobs can run and how many users can start using it, and sort of the freedom users can use it with, but also that same freedom exists currently on the login node anyways. They can already jump in and clone whatever they want. So they already have that responsibility of what they're doing on a login node, especially one that's multi-tenant with other users present. So I think Jacamar was just meant to provide you enough flexibility to keep enforcing that. And in the cases of some of the runners, some of the server stuff, we have some examples in the docs about like some things you should think about turning on or off, as well, like not letting users change their username as a default behavior. But if you are using LDAP, it's turned off by default. If you're using something like SAML, they might still be able to do that, in which case you might have to make some modifications to your configurations.
So, Wooter, hopefully that answers a fair number of your questions. We run Jacamar, I guess, at Livermore. I can say that it's run across the Department of Energy and at many of the labs where we are very strict about security. And truly the aspect of, yes, it is a rootful service at the deployment level, but it is downscoping all of the users' actions into their own accounts in a way that they would already be able to go run all of those commands, by hand. The fact that Jacamar is running it from a script that they wrote doesn't change any of that. And yeah, so it's also not opening ports on your login nodes. It's reaching out to the GitLab server rather than the GitLab server like pushing data in. So there's nothing that you need to change on the networking configuration side there. If you already have a GitLab instance hosted by your institution, and that GitLab instance is accessible from the login nodes, if your users are always already able to like pull their code and data from, then it doesn't change anything from the security posture on that side. But I think it is a good idea to potentially write a very specifically scoped document to like the security team at an institution, talking about, threat assessments of, here is why we don't believe that Jacamar increases the likelihood of your HPC system getting pwned or data getting accessed from machines when configured correctly. And here are a couple of recommendations surrounding that.
And if running as root is, it will always need some sort of privileged operations in order to run setUD, setJID, but there is an option where Jacamar auth can be run with setUD, setJID capabilities, and it will force some additional rules on itself, like you can't give Jacamar auth those capabilities and have it anything but 700. It will fall over the moment it starts, because it's going to say, oh, you've configured me incorrectly. I can't be given capabilities and be as like 755 permissions. So like things like that as options as well, if that helps make it more palatable. And I know we run it that way as well, where it's not run as the GitLab runner process isn't run as root, it's run as the GitLab runner user, and the GitLab runner user has the permissions to the capabilities in the Jacamar auth binary.
So Wooter followed up a little bit that he is, we're specifically talking about institutions hosting both the Jacamar runners and the GitLab. In his specific case, it seems like they want to run one GitLab instance over a couple of different centers. If you want to talk about it, this is something that we have implemented at DOE in between, I guess, the NNSA tri-lab, so Blanel or Los Alamos, Livermore, and Sandia. And I think Paul can talk a little bit. Some of that is in the run as script, where you're looking at an OIDC provider. In our specific example, we're using OneID from the Department of Energy, and then using that and kind of the DUID, which is a DOE OneID. Every like DOE employee gets this account number, and then we can use that to map to your local user at each individual site. But I'll let Paul follow on that a bit more.
Yeah. So if you look, if you're running across multiple sites, chances are you have different login, like you kind of federated login across different locations. GitLab maintains a mapping of user identities. So it has its primary one, like in our example, like Paul Bryan was mine. But if I logged in from different sources, it will map whatever that UID is from that authentication provider to that GitLab, what they consider the concept of the user. And in that run as docs, we provide an example of how to expose that to the run as script, and then you can make that decision. So I think it's just, you can actually verify, hold on, let me just double check to make sure I give you the right command. Sorry, I got logged out of GitLab.
Oh, no, you're good. No worries.
Yeah,
Um,
two-factor in.
I can, in the meantime, we have one other question of talking about kind of best practices surrounding reproducibility for user environments. Um, and I guess I can talk a little bit for that from, as Paul said, like the Jacamar is going to do a new bash login for you. So anything that you want to put in your bash RC or something gets loaded. And this is both a good and a bad thing. I mean, it creates reproducible nature for your users for the perspective of when they go and run a script and there's something special in modules or something loaded into their, like Etsy profile. Jacamar is going to inherit that as well, and you're going to get consistent behavior. This does create problems when working in teams because if folks have different bash RCs, um, you can often get into a weird situation where like the workflow works for me but not for you because there's some kind of external dependency that I didn't realize was in my bash RC or that I was loading into my user environment that somebody else wasn't. Um, in that case, I would say, something like a Python or virtual environment or SPAC environments, if you're using SPAC at your specific HPC center, can help with that a lot, where you can basically ignore the, bash RC or the profile and then use, like a full path to a SPAC environment, have that load all of the dependencies that you need for some piece of tooling for the reproducible workflow. Also, containers are really great for that, right? So using something like the podman run mechanism, you can create a container that has all of the tools, maybe like a bunch of linting tools or tools that you need for your unit tests. You can put those all in a container and then share them with your whole team just through loading that container, pulling it from a registry or something when you go execute your workflow.
And
Sorry.
the other option there is the the Jacamar underscore CI underscore shell equals 1. It will be set to 1. That variable is provided when the login shell is started. So if all else fails, and the user or your own, or in my case, my own environment was breaking things, I just put that wrapper where before whatever it is in my login shell and just exit the login shell at that point, um, and skip the rest of it. So
Paul, I don't remember, is there an environment variable you can give inside of your workflow that tells Jacamar not to load your bash RC or like that gets passed to that bash login execution?
no, not currently. We've explored that, and it's led to a lot of odd behavior in terms of some sites where that would not load anything, or some sites it would still end up loading their profile because Etsy profile will still end up sourcing their login shell. And so
Mm.
it was very inconsistent. It's something I've thought about adding back in if there's interest in it, but it does put some of it in a like an odd location, odd space where it's like some of your commands will not work anymore. Like suddenly nothing required to interact with the scheduler is loaded in your environment and everything falls over, and then you're on the hook yourself to do that, which some users would be okay with and some not. I'm not opposed to adding that necessarily, but it puts a lot of the pressure on the users and then potentially admins when they start having questions of why is nothing working? And yeah, I that's a
No, and
concern. Yeah.
yeah, and so I think that's a good example of why, just as you're onboarding people on your team, make them aware of this specific environment variable that they can go put into their bash RCs to exit early if, that is causing issues for, if they have like a default SPAC environment, or they might have like a conda environment or something that is messing with or has different versions of a tool installed than the rest of your team does when you go load something else. Um, Wooter did the discussion and Paul sending information about like the user API and using different OIDC providers um, help with your question? Specifically, I guess, if you're standing up the GitLab yourself to federate across a couple different institutions, as long as those institutions have publicly accessible OIDC providers, you could do that mapping internal to the API. That would be really nice. Else, perhaps, writing a custom run as script that is checking either LDAP or something at a specific institution is kind of the like last mile. You have to go implement the way to figure out different identities at different sites, but at least it's a way for each site to control that. Okay, cool. Glad that was helpful. Okay, I guess I have one last question that we often get asked. It relates back a little bit to the disconnect with a job has started, but it's sitting in like a Slurm queue or something. Um, Paul, do you want to talk at all about like there is this new fleeting functionality inside of GitLab that we've looked at, but it's not really there yet. But we are pursuing directions and working with GitLab potentially one day to have it so that your job shows up as pending or queued rather than running when it's in a Slurm queue.
Yeah, I know there's upstream actions in that space. Um, it's not something that's going to change anything with the custom executor or current deployments anytime soon. That is multiple major versions away if it once it comes to fruition. But GitLab is using something called, like you said, the fleeting plugin or the fleeting runner. And it is more of an idea that it is used now for their supporting like AWS or Google Cloud resources where they need to stand up resources and scale them up and scale them down depending on how many jobs they need or how many are incoming. So I think there's a lot of excitement there. I think there's a lot of functionality in that sort of workflow that would benefit running jobs like in Jacamar a lot. But that's still a long ways off because like so much of the custom executor we use every bit of it. Like there's a feature there, we're using it, or we have a stream to a change to get it there. So we're that's something that I think having that flexibility, especially before a runner accepts jobs, is key to solving that. But unfortunately, right now, it is one of the largest pain points, and the only thing I can say is increase the timeout, try scheduler actions, and those are the only technical solutions available to us, and everything else is kind of it is a frustrating point, yeah, but we'll eventually find a solution for it.
Yeah, and unfortunately, it's outside of the scope of Jacamar, like you're talking about, right? Like, the GitLab runner, at the point that it starts executing Jacamar, has already said that the job is now running, and it's already, counting down that timeout. So there's not really anything that we could do to say that, no, this job isn't actually, or this job is like paused or sitting in a queue. But I think it is interesting and still something that we're actively interested in pushing on to someday, not anytime soon, not that we have like a timeline, but someday soon or someday in the future, we would like to support a use case where when you're sitting in a batch scheduled queue, that it's marked as sitting in the queue properly in GitLab.
So I was kind of wondering, so the typical GitLab runners have this idea of producing artifacts, right, that you can inspect later. And so I was wondering, do you have any capability of sanitizing that or like imposing limits on filling up your sort of your storage side? Like, I was wondering how you handle that side of things, or is that more on the GitLab side?
That is more on the GitLab side. Jacamar will run the artifact upload and download scripts, but the GitLab server is going to still enforce whatever behaviors are configured in terms of maximum artifacts like length, lifespan, and also like the storage size per pipeline. So if you have a particularly limiting storage size, you're still going to hit that 100 megabyte default or whatever it is, has been configured as.
Okay.
One way to kind of get around that that we use in SPAC a lot is instead of using artifacts in our pipelines, we've gone to using the OCI like container registry, because an OCI container registry, like you can effectively push and pull arbitrary blobs of data out of that registry, and the limits for that are much higher, and it seems to scale better than artifact upload and download for us. So
Okay, that's good to know. So then, do you have, if you use the OCI method, do you have some provenance for like what job that was submitted from, or?
You don't really, like, you would have to encode that data yourself. You could do that by putting like a tag on a piece of like a binary blob that you upload. So like typically for a container, right, you would have like the name of the container, and then you have like the colon and then the tag after that. So latest is most common, but you
Oh, I
could
see.
put, the name of the job or something inside of that if you wanted to do that.
Okay.
Also, like, I guess handily enough, often for us, we have shared file systems in the, HPC and clustered environment. And so you can save off that file to a specific location from one job and then ingest it and use it in another job if you need to do it that way too. Yes. So Jacamar, for all of your users, Jacamar by default creates a .jacamar-ci directory. And a lot of our users will actually, for one side of things, you can take that directory and you could move it, and then you can symlink it back into your home directory. And you can put it on Scratch, or you could put it on a larger, something like Lustre or a parallel environment that is not your home directory. So you could do something like that where you, as long as there's a symlink from that location in your home directory, you can point that anywhere you want. But yeah, because Jacamar is executing as a full user, you can push and modify files outside of the Jacamar project directory itself. So you could, you'd have to be aware of concurrency levels if you're having a workflow that has the possibility of multiple concurrency, or running across different users. But we do often do this for workflows for like SPAC build farms or something at Livermore. We'll have people push and pull into an NFS mount space outside of their Jacamar like project directory, and you can just use the shared file system that way. I'm trying to think of all the environment variables that I use from GitLab to make sure that that's thread safe or that that's concurrency safe. I could find a list of those and send it to you, Wouter, if you want. But essentially, you probably want to check on like the name of the user. You could check what's the ID of like a merge request. If you have a bunch of merge requests running on a specific repo, you can get access to that merge request ID, and then you could have it be, each merge request runs in its own downstream space from that external spot to like push artifacts into that. And then you could have your concurrent like runner ID even farther down on that. Yeah. Okay, cool. So yeah, in that case, you could just push to a shared file system since it's in the same pipeline and is the same user. So you might just want to tag it with like the merge request or the branch that it's currently running on, so that different users potentially running at the same time wouldn't overwrite each other's space or something. Just in the case that you have like multiple pipelines concurrently executing